Okay, so in this video, I want to go through all the information we're going to need in order to do some calculation questions later on. So we're going to start off by looking at some formulas, rearranging those formulas before in my next video where I'll do some examples, exam questions. So let's get started straight away. So we've got the lens equation. Now I've drawn out a lens diagram already, but the formula you need to remember is that 1 over the focal length is equal to 1 over the object distance plus 1 over the image distance. Okay, so that's our first key formula. So just to recap, we know that F is our focal length, U is our object distance, and V is our image distance. Okay, and again, we're going to do some more examples in the next video, but just for now, let's get some key information done. Another formula we need to know is that magnification is equal to image height over object height. So just call that image height and that one object height. So again, that's another key formula. And we also have that magnification is equal to negative. Now it's really important to not forget the negative sign here. Again, that'll make more sense in the next video. That's a super common mistake. So we've got our negative sign. Okay, so now we've got those two formulas. Well, what we can then do is we can combine them together. We've got m on both sides. So that must imply that image height over object height is equal to negative v over u. Okay, and then from there we can make a few rearrangements, but for example, this could tell us that then v is equal to, well, if I multiply by u, I get image height over object height times by u, and that's all going to be negative. Okay, so all I've done is multiply by u. So again, everything in red is what I'd recommend remembering. Everything else you can work out from there. Okay, so now let's look at the sign convention for lenses. So before we go on to that, we just need to note that the focal length for a convex lens is positive, so it's bigger than 0. So f is greater than 0 for a convex lens, so it's positive. Focal length is less than 0 for a concave lens, so it's negative. Again, this will make a bit more sense when I go through some more calculation questions in the next video. But again, let's also note that distances along the natural path of light these are going to be positive, so are positive. Okay, so what I mean by that is if I draw in my lens, I'm going to draw my principal axes. I'm going to draw in my object like that. Now, if you imagine light from this object is coming from every single point. So we've got light from the tip, so someone's head, for example, light from someone's chest, light from someone's legs. Okay, so we've got light coming in from all directions. Okay, so naturally light travels in a straight line, so it's going to travel to the lens. Okay, well that distance is going to be positive because that's the natural path of light. That light's going to travel through the lens and continue going in a straight line. Okay, well that's positive. Now any light that we trace back, so for example when we're forming virtual images, well the natural path of light is to the right, so anything to the left must be negative. Again, don't worry too much about this now, this will make more sense in some calculations. Now let's look at a couple of cases of when this will be useful. So case 1, let's draw a quick ray diagram. So this is going to be for a convex lens, so we know that f is positive. Okay, now we've got u, so the object distance u is larger than the focal length, so you can either remember that from one of my previous videos, or we can just work it out the fact that that forms a real image. So again, I'll draw my parallel ray through the center. Okay, so I've got a real image, okay? So my focal length is positive because we've got a convex lens, okay? The natural path of light is to the right, so my U is positive. And then my image is also formed by light that touches that point that's also moving in the natural path of light. So V is positive. Okay, so all three things are positive. Okay, now let's look at a different case, so case 2. Now if you remember, all diverging lenses or concave lenses form virtual images. So let's draw in. It doesn't matter where I place the object with respect to the focal point, we're always going to get a virtual image. Okay, so draw my parallel ray, trace back from the focal point, and that's the angle it diverges at. Okay, draw my unrefracted ray through the center, and we get an image formed over here. Okay, but notice the image is formed where the rays only appear to meet, they don't actually meet. So U is positive because it's following the natural path of light. F is negative because it's a concave lens. And this time V is negative because the natural path of light is to the right. So this direction is positive, but to actually find this image we have to trace backwards, and we use a dotted line. So we know that that's not the natural path of light, so therefore V has to be negative.